joining this channel. We are in a day 17. So those who already visited day 1 to day 16, so they already know what I am building up. So right now we are in day 17. That is very important. Model Context Protocol, MCP. .NET Semantic Kernel and Azure OpenAI we already using from the day 15. Azure, sorry, from the day 15.5, 16, and we are now in a 17. But from before day from day 1 to day 15, it was the Olama. So what is the goal? So agent allow to call external tools and APIs. You know, when you're calling SQL Server, when you call a database or third-party APIs. So this is something out of the context for agent, right? Something external. When you're calling external things, that time we need a standard protocol, and that standard, just like in a web browser we are using HTTP protocol. If you are sending message through TCP, there's a TCP protocol, HTTP protocol. Similarly, we need a standard protocol for communicating with third party APIs, database, GitHub, any tool outside the context. That is called standard protocol layer. So instead of agents only using LLM, see, only we cannot depend on the LLMs, right? LLM can do a hallucination. Yes, definitely we are giving a prompt and everything, but at real time we need to call the third party APIs or a database or the tools. I think we already introduced the tools in the day 12. So it is like a enhanced version of the day 12 in the day 17. But day 12 actually specifically calling the inside tools within the context. But day 17 is external. I will discuss the difference between that in the PDF. So now the agent can talk to LLM. LLM will first contact the MCP to get the data from the tools and then the response. So foundation of enterprise AI system. So problem with LLM, only LLM can reason but cannot directly access the tool. LLM cannot access the tool outside, right? LLM only work on the based on the trained data. But what if you want to access the database? Or you want to access the Git repositories, want to use the DevOps API, security scanners. Those are external company, external tool, right? In that case, MCP will help. What is MCP? Model Control Protocol allow AI agents to interact with external tools. Always remember this word external tools. They're not saying with the tools that we already covered in day 12, 12A, 12B, 12C. External tools using a standardized interface. So what is the architecture? Is the request agent runtime will call agent runtime MCP tool gateway will be the tool gateway. Why tool gateway? There are multiple tools, right? That's the reason we are using a tool gateway or tool facade, which will call internally this code matrix, security scan, Git info, right? And then all the information will be sent to the Azure OpenAI. Earlier it is Olama and OpenAI. Why MCP matters? Tool interoperability, modular agent architecture, enterprise system integration, and safe AI tool access. So code matrix today are taking security scan, Git info, and DevOps API. So you can see the user request agent runtime, agent router, MCP tool gateway. Tool gateway actually having a multiple tools, maintaining the tool registry, and then the tool information will be passed to the Azure OpenAI. OpenAI through the Azure Cloud Foundry, and the OpenAI means GPT-4o Mini. That model will return the response. So tool registry, as I said, we are using multiple tools, right? So that tool need to be registered. Agent cannot call directly the call the tools, right? In the tool are registered in the tool registry which resolve the tool request. So what will be the demo? They just submit the code. Agent requests the tool data. MCP gateway execute the tool, whichever tool we need. Tool result will be written, and LLM generate final response based on the tool results and our system prompt. Enterprise use cases, automate code review process. We can do that because when you do automated code review, you have to contact the GitHub, you have to contact the PRs, right? So all external DevOps pipeline. We will show that how the DevOps pipeline assistance is working. Because in DevOps pipeline, you need Jenkins, maybe Azure DevOps or Octopus, right? The external tools are there. Security analysis, Burp tool, or any Sonar Cube tool that also you can use. Enterprise knowledge assistant. So these are the use cases for day 17. So in day 18, we will discuss, you can say almost like a day 1 to day 17, a combination where planner, MCP, multi-system all will be there. So let's go to the PDF. PDF now technical deep dive. So connecting AI agents to the tool and API, as I said, technology stack is same. Only the MCP has been added. The episode introduced the tool enable AI agents. What we are doing, code analysis, multi-agent, all things we have done, right? Now, agent and everything architecture until day 16, what we have done, we have multiple agents, OpenAI, runtime, that we have introduced, multiple agents. But still has limitation. Limitation is LLM can give you the reason but cannot directly interact with the external system. If LLM needs some external help, suppose LLM is trained on 2025 and you are 2023, you want the latest data. So LLM cannot give the data, the latest one. So LLM, what LLM will do, LLM will use his trained data of 2025. Along with that, you will access the data from the externally through MCP to get the latest information, and altogether on the system prompt, trained data and the data received from the tools will be used to decide the final response. That is called real world automation. Retrieving data from database, Git, DevOps, all are external. So what is MCP? Now agent, MCP external tool. Always remember external tool. Huh? So what we will request runtime that we already discussed. So now we have a multiple tools that will be used. We have multiple agent till day 16. Now we have multiple tools. So instead of tool calling directly, the system is a tool registry, because tool registry like it will contain all the registry and that will be called dynamically. So what we will do in the example, we are taking code metric tool, analyze the code. Suppose I'm giving, it will give you total lines of code. Detect basic vulnerabilities, it will give this response. Retrieve repository metadata, it will give commit count, last author, and everything. So agent workflow within the MCP, agent receive the input, agent call MCP tool return the result data, LLM use the data, final. There is nothing wrong. Code metric, security tool, and then the OpenAI. Benefit: adding MC into major advantage, modular architecture, tool interoperability. This pattern is used in OpenAI calling AutoGen, LangGraph, Enterprise AI agent platform also. Enterprise use cases, as I already said in the PPT, DevOps, pipeline agent, security agent, enterprise agent, all are enterprise. Day 17 demo that we already discussed what we will do. We will take a sample file, then MCP call, tool return. Key concept what we have learned? We have learned that LLM is not enough. We need the tool support also. Model context protocol architecture will give that option. Building a tool registry, implementing to MCP tool, integrating tools with the AI agent. Real world enterprise AI platform, multiple planar or MCP tool. This is a project we will use agent. We have only one agent, but it will contact this MCP server, MCP tool, code metric, security scan, GTN for the external tool. This is for connecting the Azure OpenAI. This is the result, and this is the file on which this will be acted upon. So transition to day 18, we will do all those things together. So what is the difference to day 12? Whoever visits the day 12 and day 17, day 12 also talk about the tools, and day 17 also talk about the tools, but tools through protocol. But 12 doesn't have any protocol, but it's CBS tools. So what we have a local tool, insider tool, code analysis kind of thing, structural output we have made, intelligent X selection, smart router, all are local tool related. But day 17 comes with the external tool where we are connecting to GitHub, Gitrepo, then SonarQube. These are external tool, right? So in that case, or database, the day 17. So example, suppose you want to agent want to monitor pipeline failure. What external tool? Jenkins, GitHub, Kubernetes logs, all external tool, right? And what will workflow? The get pipeline status, check log, find root cause, and suggest fix. It will check the status. If it says fail, then log the check, then find the root cause and suggest the fix. This is the agent workflow. And agent will use these external tools. And what about the internal tool? Like metrics, complexity, security, the developer productivity tool, all are internal tool. When I say developer productivity, internal tool, but failure pipe checking in the pipeline, it is a external because we are integrating with GitHub, Jenkins, and Kubernetes. So we'll do some demo in the code one, that is analyze code complexity, check security. If only the code complexity, you will run this MCP tool. If it is security, then security scan. Give full review, then code review and security. So all will be done. So let's go to the demo now. So you can see that we have a agent, MCP agent. MCP agent actually contain tool router, tool registry, and kernel. Kernel is semantic kernel. It will run. So agent will take care of all the individual external tool. So external tool are kept inside tool, code metric tool, Git info tool, name and executor, security scan tool, a tool repository. Tool. So what will happen? This is the same file we have taken. Program.cs. This is the Olama one, but Olama is not giving the right output sometimes. You have a limitation. So you have a Azure OpenAI. How to connect this? Every details has been given in day 15.5. Now once you create, then MCP agent will be initialized. MCP agent is dependent on kernel, router, and registry. So kernel will take care connecting to the LLM. Router will take care of routing based on the routing, and that will show. So let's go to tool router. So tool router will decide which to be executed. Then routing, tool router. So these are the external tools. One is code metric, which is implementing IMCP tool, GitHub, security, and all are covering under tool registry. So hope you understand that in the program.cs, we are first building the MCP agent, which will initialize your kernel, router, and registry. Then read the file, and then you call the agent async. Agent is nothing but MCP agent. So all based on the request, the router will take the decision. The router decision will be checked, and based on that, the individual tool will be called registry get tool, tool result. Then finally we will get a tool context, final prompt to kernel. So here we are using semantic kernel to connect, final prompt being made based on the decision given taken by the router, which will call internally individual tools. And once this is done, then the final output will come. So I hope you understand the purpose, that these are the tools, have the code. These all get called from the tool router, sorry, MCP agent, router, then registry, add, and then LLM will take the decision based on the tool context. So let's run it. Initialize kernel, router, and registry. Read the file. So we are requesting for review code, which quality and security means all. Code is given. Router will take decision. So only the code quality and the security we have mentioned. So the JIT info is not required, because request is for code quality and security. That's the reason. See, the code metrics and security is true. JIT info is false. Now we are adding tools. Similarly for security scan. Then tool context is ready. What is tool context? Code content 16 line hard coded password detected. These are being executed on the tool itself. Now we are sending these to LLM. See, if I use the Olama, it will take too much time, but since we are using cloud, the result came quickly. This is the cloud details. See, another tool, code complexity, hard code password, recommendation, conclusion. So hope this thing's fine. So only we are trying to show that the tools are being used, which are external, and LLM take the decision based on the tools. In the day 12, we have done using the internal tools. So it is